Okay, we're going to start on 11.2, and our first step here is working on simplifying. So if we have something inside of a radical symbol, and we have something like this as an example, 2 over 72 within that radical symbol, we want to treat this as though it was in parentheses. So we always want to do what's inside the parentheses first, which if I can simplify that, which I can divide both of those by 2, I'm actually saying the square root now of 1 over 36. And this goes back to what we've done before. So you have the square root of 1 over the square root of 36. I can simplify that. The square root of 1 is 1. The square root of 36 is 6. And we have now simplified this radical to 1/6. We can simplify within the radical symbol first and then create another fraction. Let's try another one. If I have something like this where I have the square root of 3 squared plus 4 squared. Again, I want to treat this as though it's in parentheses. So I actually want to work out 3 squared plus 4 squared first, which is 9 plus 16. And I have that in a square root, or in a parenthesis, and I'm saying the square root of that. This is the square root now. I want to add this out, is 25. So the square root of 25 is 5. We've now simplified it. Let's try one more. If I have the square root of x squared plus 10x plus 25, this is what we've done in previous chapters. I know that this is a perfect square trinomial, this right here. So this is actually x plus 5 squared. And I'm saying the square root of that. X plus 5 squared, I can double check this by saying, okay, this squared is x squared. 5 squared is 25. When I multiply them together and double it, it is 10x. So I know that it is the square root now of x plus 5 squared, which gives me, when I take the square root of a square, they cancel each other out, and that just becomes x plus 5. Now, your book tells us to go ahead and make that as the absolute value because I could say it's a positive or a negative. If you just gave me x plus 5 is that simplified version, that would be okay as well. Okay, the next step is working on a property. So our first property is the product property. That just means that we are working on the product. We are multiplying. So if we have the square root of 4 times 25, I would multiply this out. I'd find that product, and it's the square root of 100. Now that is a perfect square, which is 10. I could also separate these two and say the square root of 4 times the square root of 25. Square root of 4 is 2. Square root of 25 is 5. 2 times 5 is 10. So I should get the same answer no matter what. That is proving that product property. So another possibility is if we have the square root of, say, the square root of 18. I can separate this out to the factors of 18, and this is what we've done before, where we're finding the different factors that multiply to 18. I want to work with one that creates or uses a perfect square. So in this case, 9 is my only perfect square. So the product of 9 and the product of 2 is 18. So the square root of 9 is 3. This cannot be simplified, so it remains in the radical symbol, and that is my simplified version. I could also do something like this, the square root of 75. My factors of 75, I know that 25 is a factor of 75, and when I multiply it by 3, that gives me 75. The perfect square of 25 is 5. The square root of 3 would remain within the radical symbol, so that's the simplified version. I can continue on with, if I have the square root of x squared, y squared, this is what we've done before, where we're looking at the exponents and we're just taking half of that. So the square root of x squared is x, the square root of y squared is y, and that is my solution right there. It eliminates that radical symbol. So again, if I have anything to an even power, when I'm taking the square root, I'm just taking half of that exponent. So x to the 6th would be, the square root of that would be x cubed. Y to the 8th, the square root of that would be y to the 4th. We've now gotten rid of that radical symbol. Let's take it one step further and say that we have a number and a variable in there. And I'll go ahead and throw one in that isn't an even exponent. So I want to work with 48. And what are my factors of 48? I have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So 4 is a perfect square and 16 is a perfect square. I want to use the larger perfect square. So 48 here is going to be the square root of 16 times the square root of 3. And then I have the square root of a squared and the square root of b. And I'm going to go ahead and separate each individual thing. This is using that product property. With that, the square root of 16 is 4. A squared has a perfect square, so that is a. And then these two cannot be taken the square root of, so they go ahead and remain within the radical symbol, and we put them back together, and there's our solution right there. 4a times the square root of 3b. Okay, our next property that we're working with is the quotient property, and that just means that we are taking the, the division. So if we have the square root of 5 over the square root of 9, in the same way that with the product property we could smush them together, here we can separate them. So this is the same thing as saying the square root of 5 over the square root of 9. I can actually take the square root of 9, which gives me a 3 on bottom. This right here cannot be simplified, so it remains with the square root of 5 on top. Okay, let's try another one. If I have the square root of a to the 4th over 81, I can go ahead and separate that out to the square root of a to the 4th, the square root of 81. Anytime I have a variable, I look at that exponent right there, and it is an even number. So with the square root, I'm just taking half of that to eliminate the radical symbol, and the square root of 81 is 9. I have simplified that using the quotient property. Let's go ahead and say that I cannot have all even variables. So let's say your book uses this example with an a to the 5th over, we'll use that same 81, and I have the a there. What I want to do is go back to the beginning of the lesson where I can simplify anything inside first, treat this like it's in parentheses. Now I can simplify it to a to the 4th over 81. I'm still taking the square root. So then I separate it to the square root of a to the 4th over the square root of 81. Again, I'm going to look at this right here. It is an even exponent. So when I take half of that, it is a squared. The square root of 81 is 9. I've now eliminated those radical symbols. Let's try one more that is a little bit harder. So we have the square root of z to the 5th, and we have the square root of 25y squared. So again, I'm going to go ahead and separate top and bottom. Keep them within radical symbols. Now, this z to the 5th, I don't have an even number, so I'm going to go ahead and use that product property to separate it so that I do have an even exponent for this first one. And then I'll separate this number and the variable. Now, what I'm going to do right here, the square root of z to the 4th, again, I take half of that exponent, so it becomes z squared. This is an odd exponent and it's by itself now, so I just leave that z inside of the radical symbol. I can take the square root of 25, which is 5, and the square root of y squared is just a y, and there we go. All right, your assignment for 11.2 will be numbers 2 through 42 even. That is going to start on page 708. If you have any questions, let me know. Good luck.